Welcome to this lesson on domain, range, and function. Before we begin, make sure you have your note sheet from number 23. Okay, a nice pencil, and be ready to use the backside for any scratch work that we will have to do, beginning with this next slide. So I'll pause the video, make sure you go grab that worksheet. Let's begin. How do we read these inequalities? So take a look around. If you want to pause the video, pause it, and test yourself. See if you can write down how to read these inequalities. This first one says that x is greater than 6. Okay, we always eat the bigger side. Over here, we have x is less than 10. Okay. This says x is less than or equal to 3. That little line underneath, that little extra line underneath means the or equal to. If you tested yourself on this one, this says x is greater than or equal to -8. And the last one would be tricky. You might not have seen this before, but it says that x is between -3 and 8. Or you could say x is bigger than -3 and less than 8. Let's review some key items. Remember, our domain represents the x values, and the range represents our y values. Now, as we get going into these examples, again, pause the video now if you don't have your worksheet for number 23. It has all the examples that we are going to go over. As you see on the left here, I have our nice poster that I'm going to be referring to throughout this video. We're going to begin in the middle of your worksheet in number 5. And we need to find the domain, the range, and ask ourselves if this graph is a function. Well, before we figure out what the domain is, we're going to ask ourselves two questions. Does the graph go to the right forever? Does it go to the left forever? Arrows are what indicate the graph will extend forever. When I look at this graph, I see that arrow, which is pointing to the right, and this arrow, which is pointing to the left. Meaning, does it go to the right? Does it go to the left? My answer is yes to both. Therefore, the answer I put down on the line would be this fancy R, which stands for all real numbers. When we go to the range, we're looking for the y values. So we ask ourselves two different questions. Does it go up forever, and does it go down forever? Well, this arrow is going to continue to go up, and this arrow is going to continue to go down. So we would say yes to both, in which my answer is just the same as the domain. It would be this fancy R, which stands for all real numbers. Now, to determine if it is a function, we use our vertical line test. So let's say I've got a vertical line here. The way we determine is if I can drag this vertical line and it crosses more than once, it's not a function. As you can see in this graph, that never happens. Therefore, is it a function? Yes, it is. Now, we're going to skip this. This is part of the poster. We're going to go into number 1, in which this is a special case. in which we won't be using our poster because there is no graph that extends. These lines are, there's no lines in here, there's just points. So all we need to do is to go to each point. So for instance, this point has an x value of -3 and a y value of -4. So -3 would go in the domain, -4 would go in the range. And I do that for all of the points. This point is at -2 and the y value is 5. So I'm going to put -2 in the domain and 5 in the range. Here I have a x value of 1 and a y value of 3. So 1 goes in the domain, 3 goes in the range. X value 1, y value -2. So 1 goes in the domain and -2 goes in the range. And my last point is at 4, 0. So 4 goes in our domain, 0 in the range. Now, to determine if it is a function or not, you can notice that the x values repeat itself. Or you could draw a straight line that goes through these 2 points right here and determine that this is not a function. Let's continue. Number 2. Again, ask ourselves 2 questions. Does the graph go right forever? Does it go to the left forever? As you notice, there's no arrows in this graph. It's a shape. So we would say no to both for the domain. When I say no to both, I'm looking for the left edge of the graph. Let me get a little closer than that. The left edge of the graph would be right here. And the right edge of the graph would be right here. So to write this, I'm going to put my less than or equal to with x in the middle. And I'm going to use my left point. Well, that's -3, so that's going to go on the left. And 3, which is my right bound point. I'm done with the domain. Let's move on to the range. Does it go up forever? Does it go down forever? Again, you would say no to both. So we look for the bottom of the graph and the top of the graph. So I'm going to copy this down, and now I'm looking for the bottom of the graph. Well, the bottom would be -4, so that's going to fill in there, and the top would be up here at 3. I've done my domain and my range. Now we're looking for, is it a function? Well, if I draw a line right here, it's going to cross this graph here and here, so no, it is not a function. Let's check out number 3. For the domain, I'm going to say again, does it go to the right forever? Does it go to the left forever? Well, this arrow is only going to the right, and on the left it stops. So we would say yes to right only. Now on the poster it says to use the greater than or equal to symbol, but it says use the greater than symbol if it's an open circle. I see an open circle here, so I'm going to use x is greater than. And what I'm looking for is what is the x value on the left side there. Well, the x value at this point where the graph starts is -4. So the domain is all the values bigger than -4. When we go to the range, we ask ourselves 2 questions, up forever or down forever. We would say this arrow is pointing up forever. So we said yes to up, we said no to down. So we're using option 2. Again, if there's an open circle on the bottom of this graph, if you look to the bottom, there's no open circles. So I can use y greater than or equal to 1. The bottom of the graph, the y value is 1. Now we're ready for our vertical line test. So if we take this vertical line, does it ever cross the vertical line twice? That would be no, so therefore, yes, it is a function. I'm going to let you do number 4. Refer to number 2 when you try to fill out number 4. Let's go on to this example, number 6 here. Domain. Does it go left? Does it go right? Well, this is going to continue to go to the right. This is going to continue to go to the left. So our answer would be yes to both. So for the domain, we have all real numbers. For the range. Now both of these arrows are going up. Okay, but it's not going down. So we would say yes to up only. So my range is going to be y is greater than or equal to. When we go up forever, that means we got to look to the bottom. Where does it start? It starts when y is negative 5. Using our vertical line test, is it a function? Let's make it a vertical line. Is it a function? You go across. Yes, it is. Number 7, I'm going to leave to you. Take a look at how we did number 6. You fill out number 7. Number 8 is a special case. This is the last one I'm going to do with you. Okay, this is a special case. Okay, it's not special in domain because this arrow goes to the right, this arrow goes to the left. So that's a yes to both. So the domain is all real numbers. Here's where it is a special case. These are perfectly horizontal lines. They don't venture up, they don't venture down at all. There are only 2 values in the y. This value for the y, the whole line is 3, and this whole value is 1. So there are only 2 points in the range, 3 and 1. Is it a function? We get our vertical line out again. And if you notice, it crosses twice right there. So because it crosses the vertical line twice, this would be no. Be sure you fill out the rest of your sheet, including number 9. You're going to do that one on your own. You're going to try 7 on your own. And I'm going to leave 4 on your own.